In this tutorial, we will be learning about the shape and bond angle of the covalent compounds. Covalent compounds, shape and bond angle. Before beginning our case in this topic, I'd like to tell you a small thing. When there are just two molecules in the formation of bonding, the bond angle is always 180 degrees. That is linear, because whatever the molecules be, their shape will always be linear. Suppose it be HCl or oxygen or nitrogen. Whether they form a bond in this way or in that way, either way, it's always linear. So it's always linear. Hence, when there are only two atoms involved in the formation of bonding, the bond's angle is 180 degree and the shape is always linear. So now let us consider when there are more than two atoms involved in the formation of bonding. So case 1. Now in each of the following cases that we are going to learn, we'll have a central atom, that is an atom which forms bond with many other atoms. So when central atom has two bond pairs and zero lone pair, now this case is very rare in case of covalent compound, because two bond pair means the atom must share two electrons with other two or more atoms. So this case is very rare, because for this case to be true, that and a metal should be present, and metal never make covalent compounds. So in each of our following cases, we'll consider double bond as single pair, double bond as single bond pair. So the example of this case is CO2, that is carbon dioxide. Now in this case our central atom is carbon. Now this carbon has 4 outermost electrons, and all of its electrons are involved in the formation of bonding 1, 2, 3, 4. So it has zero lone pair, and I just told you that double bond is considered as single bond. So this is considered one single bond, and this is considered one single bond. So there are two bond pairs and zero lone pairs. So the bond angle in this case is 180 degree and the shape is linear. So this is similar in the case of just two atoms. So this angle is 180 degree and the shape is linear. Now let's move on to our next case, that is to number when central atom has 3 bond pair and 0 lone pair, 3 bond pairs and 0 lone pairs. So the example of this case is AlCl3. Aluminum has 3 outermost electrons, Al, Cl, and Cl, and each of the electron is involved in the formation of bonding. So we're not concerned about other atoms, we're just concerned about our central atom. So, and since aluminum has 3 valence electrons and all of them are involved in the formation of bonding, there are no bond pairs. So in this case, the bond angle is 120 degree. That is, this angle is 120 degree, this angle is 120 degree, and this angle is 120 degree, and its shape is trigonal planar. Now trigonal means triangular shaped, and planar means all of the molecules, all of the atoms are in the same plane. So since they are in the same plane, the sum of the bond angle is 360 degree, which is a complete circle. So 120 plus 120 plus 120 equals to 360. In our first case 2, in carbon dioxide, this upper angle is 180 degree and the lower angle is 180 degree, and the sum is 360 degree, and it also forms a complete circle. That is, the first case is also the molecule is in planar shape, that is, they are in the same plane. All of the three molecules are in the same plane, and in our this case, second case, also all the molecules are in the same plane. That is why they are considered trigonal planar. Now let us move on to our third case. Before moving, I want to tell you a general trend in this case. So since AlCl3 is the example of this case, so now using the concept of AlCl3, we can write other examples such as AlBr3, AlI3, and so on. So now because in this case AlBr3 means Cl-Br replaces fluorine because they are in the same group, and I replaces fluorine because they are in the same group. So the example can be found out using the group, because an element is substituted by another element of the same group. Hence we must know the pattern and we must deduce what are the other example of this. Now for the third case mentions this: when central atom has 4 bond pairs and 0 lone pair. Now in this case, many of the students till the answer is being 90 degree, bond angle being 90 degree, but this is not the case. Most of the students divide 360 degree angle by 4 until the answer 90 degree, but this is incorrect. In this case, the molecule is not planar. Let me write an example. The example of this case is methyl. Now you must notice that in this case the molecule is not planar, that is, it doesn't lie in the same plane. So if you consider the 3 dimension, then you must know that the 5 atoms in this molecule are in 3 different planes, are in many planes. So that is why this molecule is not planar. Hence its shape is tetrahedral. And the bond angle is 109 degree, 109.5 degree in each case. 109.5, 109.5, 109.5. Bond angle is equal to 109.5. Now their sum doesn't give us 360 degree because they are not in the same plane. Hence this is not planar. Now the other example of this are since we know that CH4 is tetrahedral. So the other example are CCl4, SiCl4, CBr4, and so on. Now, one thing you need to notice here is that the total number of pairs in this case is 4 plus 0, that is 4. So now in each of the following cases the total number of pair will be 4, but now we'll have lone pairs. So we'll learn the relation between the total number of pairs, lone pair and bond pair. So let's move to the fourth case. In our fourth case, central atom has 3 bond pair and 1 lone pair. Now in our previous examples we have never learned about lone pair. Now how does lone pair affect? So let me write a general rule regarding lone pair bond pair. So when a lone pair increases, keeping the number of total pair equal, that is, in this case we have total number of pair equals to 4, and in our previous example too we have total number of pairs 4, but in this case one lone pair is increased, hence our bond angle decreases by 2.5 degree. So in our previous example the bond pair was 109.5, so now the bond pair decreases by 2.5, that is 107 degree. In this case, when central atom has 3 bond pairs and 1 lone pair, then our bond angle will be 107 degrees. So what are its example? The example of this is NH3, ammonia. Now yes, one thing, in each of the cases you must write the shape of each of the compound as I have mentioned here, because that is its standard shape. So ammonia, you must write ammonia in this shape. You cannot write ammonia as N, H, H and H. So you must write ammonia as I have written over here. So here we can see that nitrogen has 3 bond pairs, 1 bond pair, this one, 1, and another bond pair here, and the next one here, 3 bond pair and 1 lone pair. So due to the presence of 1 lone pair, our bond angle decreases by 2.5 degrees and the shape of this compound is pyramidal. The shape of this compound is pyramidal. Now what can be the other example of this case? The other examples are, since we know that NH3 is the example of this case, so other example may be, what is the other compound in the same group that is as in nitrogen, that is phosphorus. So PH3 can be the next example, and so on. Now try to deduce yourself what are the other examples that fall in the same case. So what we have learned in this video is that whenever a bond pair, total number of pair is constant, but a bond pair increases, then our bond angle decreases by 2.5 degree. Now what will happen when the central atom has 2 bond pair and 2 lone pair? Let's look at that too. two bond pairs, two lone pairs. Now, let's consider an example of this case. A very simple example of this case is water. Since you know that oxygen has 6 outermost electrons and only 2 electrons of oxygen is involved in the formation of bond. So this is one pair and this is the next pair, 2 bond pair and 2 lone pair, because the central atom is 2 lone pair. So in this case, now keeping the total number of bonds, keeping the total number of pair equal, that is 2 plus 2 equals to 4, and one lone pair is increased, so our bond angle decreases by 2.5 degree. Hence 107 degree minus 2.5 degree equals to 104.5 degree. So in this case our bond angle is 104.5 degree and our shape is non-linear. Many consider it to be V-shaped. You may write it as V-shaped, or you may call it as non-linear shape. And other example of this is H2S. Same is the case in H2S, sulfur 2H, 2 lone pair. So we are just changing the central atom here, because oxygen falls in group 6 and substituting oxygen with another element of group 6 also follows the same pattern. Hence, now in this video we have learned how the number of lone pair and bond pair helps us to reduce the shape and the bond angle of our compound. And this is only applicable for covalent compounds, because in ionic compound we don't have bond pair and lone pair, because in ionic compound there is direct transfer of electron, no sharing of electron. You need to focus on this case. So this is it for the video. In the next video we will be learning more about chemical bonding.